Welcome to tonight's All Space Considered, everyone. I'm Dr. David Reitzel. Tonight's program is brought to you by Griffith Observatory. We're owned and operated by the City of Los Angeles and the Department of Recreation and Parks. And as always, we'd like to thank Griffith Observatory Foundation, our nonprofit partner that helps in so much of what we do. Tonight, as always, I have Patrick So and Chris Butler here to bring us the show. And we have a couple of very special guests as well. We have Professors Courtney Dressing and Gabor Basri to talk all about a very special program that they were involved in the creation of, as well as some of the research and just other fun stuff they've been involved in. So we've got a great show for you tonight. Let's take a look at it. Stepping forward, first of all, like I said, Nova PBS Universe Revealed with our very special guests. We're going to talk all about that program. A couple of the episodes have aired already, but several of them have not yet. So you can get caught up, of course, and we're going to tell you all about it. We'll have our pretty pictures and solar system weather with Katie. And, there's been some weather going on out there. In fact, I even went looking for some myself. I'll tell you whether I was successful or not. There's our sky report with Patrick. As always, there's a lot going on in November, actually. In fact, something related to the song that we were playing for our opening that was so beautifully performed by our very own Bill Gruneberg. So thank you, Bill, for that wonderful performance. You know, applauses to you. That was an original performance, and that is, nobody claimed that was somebody else playing it. That was All Space Considered. And then lastly, we're going to close out our show with Chris Butler and Out to Launch and all the rocket launches that are happening and did happen, and some updates about some things that are going on out in space. So we've got a great program for you tonight. So let's kick it off. You know, we'd like to thank all of you out there in our YouTube land. We've got the chat open. If you'd like to communicate with our moderators, or you have any questions, you can type them into the YouTube chat, and we're happy to get to those as we see them. We always appreciate any of the donations people make. It helps us do these sorts of programs at our school program and whatnot. So we'll keep an eye on YouTube as we move forward in our program. First of all, Nova, of course, it is not a Chevy Nova, although this is a beautiful car, 1967 Chevy Nova SS. And that's what a lot of people think about when they hear Nova. We have a Nova you can see. If you're in a dark sky, you go out and look up, and there might be a new faint star. Sometimes they can get bright, but most of the time they're a new faint star, sometimes a binocular object. But that's not the Nova we're talking about tonight. This is the Nova, of course, that we're talking about. PBS is Nova. And in fact, it was started by and continues to be created by WGBH Boston, although they changed their name recently just to GBH, which is not the punk rock band. It's this emblem. GBH is their new one. I know, Chris, I had to do it, though, growing up in Reno with 7 seconds and whatnot, making my hometown proud there. Anyway, but GBH is still making these wonderful programs. In fact, growing up, myself, I was inspired to become a scientist, to go into astronomy by programs like Nova. My dad would put them on. One, because they were wonderful programming. You learn a lot of what's going on, but just beautiful programming as well. Inspirational programming. It elevates the science to a new level. Programs like Day of the Dinosaurs Died, Back to the Moon, The Death Dive to Saturn. I mean, they sound all very dramatic, but they are dramatic. Cassini's final dive into Saturn was an incredible experience. And of course, information all about the sun as well. And Griffith Observatory awarded these with a Star Award, not these particular programs, but the NOVA program in general. We, back in the day, I'm not sure what day it was going on, but we found these awards on our website, and NOVA was a recipient of the Star Award, which maybe we should start providing those again for outstanding programming. Now, if you go to the website today, you can watch episodes. And no, we're not talking about the edible insects, although I'm interested, certainly. I don't know if I'd try anything, but it sounds fascinating. But the Universe Revealed series, and you can see 2 of them there. We've put them all together here for you. It's a 5-part series that starts with one called Age of Stars. They move on to the Milky Way, and then talk about alien worlds beyond ours, black holes, and finally finish up with the Big Bang. So we're going to literally the age of stars. In other words, the era that stars are important in the universe. Initially, you have a Big Bang, the universe is created, there's an era where there are no stars, and then finally a first star gets created. And then finally, at some future time, and this is a view where we've taken the entire sky, essentially, and made a view of our own galaxy, do have lives. They're born, they live, they die, and they change the universe when they do that. So that's part of the story as well. It's all very exciting. I love this stuff. In fact, here are sort of our diagrams of stars living. Stars like the sun form, make a planetary nebula, make something called a white dwarf, very exotic object, but the massive stars make huge suns, huge stars. They can explode, they can make exotic objects.
And the best time to see it, this distant object, of course, is the Milky Way, is during the summer. Now here we have a star map showing the Milky Way, but where is it? Well, from our cities, we really can't see it because it's drowned by the bright lights of the city. And in fact, 1/3 of the world's population and 80% of Americans can't see the Milky Way anymore because of light pollution. So in order to see the Milky Way, we have to go to a dark sky. And here's the same view with all the lights off, far away from the city lights in a rural area where we can see the Milky Way extending almost from horizon to horizon to its brightest portion near the constellation of Sagittarius, which marks the center of our Milky Way, which is the Milky Way is such a majestic view with the dark dust lanes as you can see here. Now, we only see a portion of the Milky Way because a part of it is hidden by our own Earth. And so we really can't see the full extent of our Milky Way. Several spacecraft have been sent out far away from Earth and are able to tell from end to end away from the center. And another spacecraft before that took this image, the one on the right. And this is a Colby picture, which was able to take an image through near infrared light. And you can see that what the shape of the Milky Way kind of looks like. It looks like two sunny side eggs placed back to back. And from this and from observations of infrared and radio observations, we're able to make an estimate of what our galaxy would look like even from within. So on the left there, you can see a basic shape of our Milky Way galaxy, a barred spiral with the sun positioned roughly about halfway from the center of the galaxy to the outer arms. Milky Way has a big story and there's many dramas in the past and some in the future with the Milky Way.
Yeah, absolutely, Patrick. The story of the Milky Way is also a story of a lot of galaxies. It's not that unique out there. Galaxies are going through this, but there are a whole bunch of different kinds of galaxies out there, of course. So it's only part of the story of the universe, although there's a lot to explore. Now, in our own Milky Way, alien worlds, what does that mean? Chris,
Yeah, this is something I'm really interested in. This was the episode I was most excited to see. Alien worlds, of course, now this sounds almost like a science fiction topic. And of course, science fiction's thought about this for a long time. But what we're talking about here is the question of real alien worlds, specifically something called exoplanets. And if you're wondering, what an exoplanet is, let me explain a little bit from our perspective of what the world is and how we've had to change that. It's whatever. But the world was the world, and there was only one of them. Now, it so happens that still in the center, it wasn't moving, it wasn't turning, it wasn't doing anything strange like that. All of the other things in the universe went around us. The sun, the moon, the planets, the stars revolved around an unmoving, unchanging Earth. That was enough of a change already, but in the 17th century, in the beginning of the 17th century, we have a major revolution in thought, courtesy of Nicholas Copernicus, who realized that observations of the motions of the planets could be explained not having the Earth be a ball at the center of the universe, but instead being a planet itself, going around the sun. This idea, the heliocentric hypothesis, transformed the Earth into being one of the planets. Now, initially, it was just an idea, but Galileo, with his telescope, made observations that proved this is actually the truth. And so the people had to reinvent what the world was. The world, the Earth, was now a planet. And if you think about that, because they knew of other planets like Mars and Jupiter, Mercury, Venus, if the Earth is one of those kinds of things, it means there are other worlds. That was the first time we had to accept that idea that the Earth wasn't the only world. So naturally enough, science fiction and other people told stories about men from Mars and things like this, the idea of what it might be like to be on other worlds in our solar system circling the sun. But at the edge of the diagram, you'll see little star-like markings there. That represents the distant stars. Well, we studied those as well. And by the middle 1800s, it was very clear that these were not just little sparkly lights, but they were suns, other suns in the distance. Now, remember, we said we got the planets going around the sun in our solar system. If these were also suns, did they have planets as well? Meaning even more worlds? These would be very, very hard to find. They would be far away. They would be small. They would be faint. But if we could detect them, it would prove that the universe was filled with worlds, not just a couple in our solar system. These distant planets outside our solar system, we've come up with the term exoplanets to refer to them. Of course, now the question is, are there any such things outside of science fiction? When I went into college, we didn't yet know the answer. Just about the time I left college in the late 1980s, we found out the answer. And the answer is yes, there really are exoplanets. And you may be wondering, have we found 1, 2, 3, or 4? It's a lot more than that. As a matter of fact, there are thousands of exoplanets known today. And we actually have an exhibit at the observatory called Other Worlds, Other Stars, where we try as best we can to keep track of the tally, and the number keeps going up and up and up, and now there are more than 3,000, pushing 4,000 confirmed exoplanets, and there may be as many as billions of exoplanets just in our galaxy. So I was very excited to see that was one episode of this new show, and I'll be anxious to hear about it.
Chris, we're at 4,551 now.
4,500? A fella turns his back for a minute and they find all these new worlds.
Yeah, no,
the world used to make sense when there was just one, but I'm afraid we're all going to have to keep up with the tally.
Well,
wow,
what's
that's
exciting
amazing
about this is that these worlds are different. They're not, you know, it's providing us more examples beyond the 8 planets and hundreds of dwarf planets within our own, you know, our own solar system. So
Indeed.
Some of these are in really weird places. Some of them are really strange environments to be in. And we can talk a little bit about that tonight. It's going to be fun. Not only that, in terms of exoplanets, Nova Revealed is going to talk black holes. And black holes, weird regions. Now you can make little ones, like I said, through stellar evolution. A massive star can evolve, can explode, and make a black hole. But those are small ones, and they're probably all over our galaxy. They're all over all galaxies, and we see them. But there's also the supermassive ones down inside of galaxies, and they seem to have a huge influence on the way those galaxies evolve. So does the black hole, you know, it's a little bit of a question, is what is the feedback mechanism that goes into making the mass of the black hole track so well, the size and mass of the galaxy? The two, there has to be something going on between the two of them, and it's a fascinating story that you can hear more about watching these sorts of programs. Black holes, really exotic objects, just crazy places. Now, lastly, the little topic of the Big Bang was decided to be another topic that Universe Revealed would go for. Now, what's interesting about the Big Bang is a lot of folks think of it as the first event that happens in the universe, and yes, that's accurate. But it's also a process. It kicks off a whole set of physics that the universe then evolves by. The laws of physics are, as far as we can tell, sort of encoded into the universe at that point, and it's set going. And we need to understand how and why that happens. Now, this is sort of a more fun diagram to me because it opens up like a little bit like a horn, and the universe is accelerating. So if that's the universe getting bigger as it expands from the Big Bang, it's happening faster due to something called dark energy. So if you want to understand the Big Bang, there's dark matter, there's dark energy, there's the expansion of the universe. How did we figure out the universe is expanding? How do we even know there's a Big Bang? How do we think that there is something called that at the beginning that set this process in action? Well, some of it is the observations we've made. This amazing diagram is part of this story that's going to get told. This is the cosmic microwave background radiation. It is an image of the universe at a very early time. So find out how that plays a role. And then this is the Sloan Digital Sky Survey map, essentially, of a slice of the universe. You're seeing the galaxies. Each point represents a galaxy, and that is showing how they're arranged. It almost looks like a sponge involved in this. And the program talks about those and how all of this is one process, but it's all interwoven. And tonight, we are lucky to have two of the astronomers, two of the astrophysicists that were involved in the making of this program. So welcome to the program tonight, Dr. Dressing, as I'm making it, already stumbling over my words, and Basri, but I'm Gabor and Courtney, I hope is okay, and you can call me David. But it's exciting to talk to you both tonight. So first of all, how did you get involved with the program? Did you just get a phone call or an email? How do things like that happen to you?
I got an email. This was during the middle of COVID. So the idea of going out and seeing strangers in person was a little bit shocking. And if you watch it, you'll tell that it was COVID because my hair looks terrible. Hadn't had it cut in a long time, but it was really fun. They were doing a series about planets and stars, and I like planets a lot. So I was excited to talk with them, and they followed very safe protocol during the filming. So I felt comfortable doing that.
Well, that's excellent. Gabor, how about yourself?
Pretty
You
much
must get
the same
asked to
for
do it.
me. I got an email saying, would I be willing to consider going on this program and being interviewed and answering a bunch of questions? And I said, of course. And yeah, then there was a whole thing about, oh, we're going to, follow these protocols. They sent us a kit of, PPE and all that stuff.
Oh,
And
fantastic.
we went and did it.
Now, I like to say, did you ever imagine that participating in that would lead you here to be on All Space Considered at Griffith Observatory? Because, no, but honestly, we're honored to have you here to be able to talk about these things. To both of you, what was the most exciting? Maybe start with you, Gabor. What was the most exciting bit of research that you saw, astrophysics, that was being brought to the public through this new series?
I didn't actually appreciate that they were going to be posing it in terms of the age of stars. That's a very big concept, and I like that they presented it that way. That whole idea came from another Berkeley graduate student, Fred Adams. He wrote this book called The 5 Ages of the Universe, one of which is the age of stars, and talked about it, from the time before stars even existed to the time after the last star existed. So I loved that they turned the program into that kind of a sweep.
And now, in terms of that, they do talk about that last star, which seems a little bit of a sad notion, but they also talk about the peak star formation in the universe, when most of the stars are being made, or you're making the most per year. Are we closer to the point where the universe was making most of the stars, or are we closer to the point where that last star is going to get made?
Well, we're much closer to the point where the peak of the star formation.
Well,
So, from the point of view of the age of stars, the universe is still very young. So most of the stars in the universe that are formed lower in mass than our sun, none of them have died yet. The universe isn't old enough for any red dwarf to have died yet. So we're just getting started here. So yeah, the end of the age of stars is way off in the distance, many, many, many times the current age of the universe. Whereas the peak of star formation is only a few billion years ago.
Yeah, so that's good news. Our friend Katie Mack, who's been on the show before, of course, told us all about how the universe is going to end, and it's good to know there's a lot left, so people shouldn't be that stressed. Renee, how about yourself? What research aspect most excited you that the public would get brought?
Often when we think about planets orbiting stars, we think about planets orbiting single stars. But we know from studying populations of stars that actually a lot of stars have companions. They're in multi-star systems with 2 stars or maybe even more. So I loved that at the end of the episode 3, they talk about planets orbiting multiple stars, because that's the type of planet we have to consider if we're looking for life in the universe, or if we're trying to understand how planets form and change over time. We can't just look at planets orbiting one star. We need to look at all of the planets.
Yeah, it's I know for some arrangements you're going to have stability issues and planets are going to get tossed out, but for certain arrangements, I know it's completely fine that you can have very stable orbits for long periods of time. But have we found Tatooine yet, though? That's the one everybody wants, is Luke's planet. Of course, has the famous shot with the 2 suns rising. So, George Lucas in Star Wars got us all excited about that notion way back then. But are there any that are potentially habitable, I guess, is really what I'm asking.
So partially, it's challenging to find these planets. It makes it even harder than finding a planet around a single star. And because of the stability issues you mentioned, you typically have 2 flavors. You have the kind where the 2 stars are close together and the planet's really far away, and that means the planet's going to be quite cold. Or you have a case where the stars are pretty far apart, and then there's a planet really close to one of the stars, and that planet's probably quite hot. So coming up with a configuration where you have two stars and a planet that might be habitable is tricky. It would probably have to be in the type of configuration where the planet orbits one of the two stars, because otherwise you get a strange mix of light from both stars, and it would have very, very strong seasons as it orbits the stars.
Mm-hmm. Yeah, absolutely. That completely makes sense. Now, what do you think is different about these shows versus other shows out there to both of you? Do you find anything in these that is more exciting? I mean, certainly the graphics they're using is just spellbinding and amazing. But what to you tells you that people ought to watch this, I guess, to get the public excited about this?
Well, one thing that I did enjoy is they interviewed a lot of astronomers, and it was a very diverse crowd in all kinds of ways, young and old, men and women, different cultures, and different types of research. So in that sense, you got a flavor of lots of astronomers as well as the astronomy that was being done. It's, for my taste, overly dramatized. There's all this exciting music all the time and so on. But I understand that that for people who aren't steeped in this stuff, why would you even look at this? So it's nice that it is dramatic. But at the end of the day, they really actually presented a lot of good science. So I think that's the most exciting thing.
I completely agree. The visuals are stunning. As an astronomer who tries to find planets and study them, I wish we had visuals like that of other planets. We don't. And that leaves a lot of room for imagination. It could be whatever you want it to be, because we don't know what these planets actually look like.
Yeah, I was wondering that. Are there any planets they visualized that you thought differently? Even though, of course, people can come up with all sorts of scenarios, but were any that you were like, no, that's not Tau Ceti, C, that there's no way?
I think we're all biased by what we see. So some of the clouds looked really Earth-like to me, but that's probably because there's a lot of great video footage of clouds on Earth, and then you can colorize them and you can stretch them and you can tweak them a little bit. So I don't fault them at all. I am a terrible artist. If I drew it, no one would ever want to watch it.
Well,
I think the big lesson that we've learned in our study of exoplanets so far is nature's imagination is far better than ours. So whatever
Absolutely.
we came up with, it's probably different, and it might be really different, and we haven't thought of it yet. That's kind of been our constant humiliation as we learn things. It's like, oh gosh, didn't think of that, but nature did.
Yeah, that's completely the case. In fact, Patrick, to call you into this conversation here, that background behind you is thought you made that up. That's fake, right? Oh, you're muted, Patrick.
Got to get his confession on the record.
Yeah, get his confession.
Yes, that is computer generated.
Yeah. So, but Patrick, you like to make views from within these exoplanets and scenes with things like molten rain falling. Chris, you do as well. We have two folks that are animators as well in the room and have made these places. So sometimes Chris will say, you need to take a look at this exoplanet I've made. We have to work it into our new school program. So I know what you mean. We're in this amazing age where our imaginations can run wild about this, but we're all really hoping to find, of course, life around another planet, around an exoplanet, somewhere else. What are your top candidates, both of you? Because I know you both work in this sort of field. Gabor, you're working with the stars and seeing how they influence it. But what do you think what's your favorite candidate out there?
Well, the Kepler mission, which found a lot of those planets you were counting up, was intended to try to find true Earth analogs. That is to say, Earth-sized planets around sun-sized stars at Earth orbit-sized orbits. We didn't really find any of those. They were right at the limit of the ability of Kepler to find something like that. So the fact that we didn't find any does not in any way mean they aren't out there. We just didn't find them. And so most of the planets that were found in the so-called habitable zone are around smaller stars, and they have smaller orbits, but they receive the same energy on the surface that the Earth does. And so those are my favorite candidates, but we are really not sure at the moment whether red dwarf habitable planets are actually habitable. And there's a whole bunch of questions about them. But that, that's what makes research interesting. So I think over the next decade or two, we may be able to settle that question, because it's probably true that most of the Earth-sized planets in habitable zones are orbiting red dwarf stars. But whether that's the main site of life or not, that's unknown at the moment.
In fact, I think the image behind you is demonstrating that, although
Right.
behind you, it looks like there's probably a flare going off, and that
Yeah,
poor,
let's see.
yeah, there it is.
Oh,
I've been hiding it.
okay.
That poor planet is just going to get hammered by that, and that could be really bad
Well,
for
so,
life.
so here's one thing about those planets. That planet is close enough to that star that it is tidally locked to the star, like our moon is to us. And so the side of the planet that's getting hammered there keeps getting hammered, sure enough. The backside of the planet, though, never gets hammered. It has no idea there's a star there, even, basically. And so, you can ask yourself, well, and one of the things people worried about early on about a planet like that is, it's going to be awfully cold on the backside with no star ever shining. Is the atmosphere going to actually freeze out there? And of course, if it freezes out there, then more atmosphere will come back around to replace it, and it'll freeze out. And pretty soon you'll have the whole atmosphere of the planet piled up as an ice layer on the backside. It turns out, though, that if you have enough of an atmosphere, even like the Earth's, it brings enough heat around to the back that doesn't happen. So you can imagine life on the backside of that planet. It has to be very cold, cold adapted life, but it could be, say, under an ice shell back there. There could be volcanic vents. The bottom of the ice could be melted. We can get into a Europa type situation. So I'm not willing to write these planets off, but they're not like Earth. That I will be happy to admit.
Yeah. Courtney, what about yourself? This is the field you work in. First of all, what excites you about exoplanets, and why do you study them? And is there one that you think is your favorite candidate for us to discover?
Well, as a kid, I loved science fiction. So I was always interested in the idea of trying to find life on other planets. And I feel very fortunate that I happen to be an astronomer at a time where that's actually something I can say to my colleagues and they won't laugh at me, because now we have these planets and we're getting the ability to look for life on them. We have a big report from astrophysics saying that, yes, that's the direction we should go for the next 10 to 20 years. It's not science fiction anymore. For me, there are a couple systems that are intriguing. There's one orbiting a little red dwarf star called TRAPPIST-1. It has multiple transiting planets, and there's some that might be too hot, others that might be too cold, and a couple that might be just right. But we don't know yet. We need to really understand the properties of these planets. We need to know their atmospheres. We need to know how much they weigh. We need to know what they're made out of. And by having multiple planets that are contenders in the same system, we can compare them one after another. And then we can try to explain them without life and see if we can do that. And if we can't, that's probably a sign that maybe there's life on one of those planets. Hopefully, with the James Webb Space Telescope, which is launching in December, so just about a month away, we'll get observations of these planets that will show some signs of what's in their atmospheres. It might not be enough. We might discover that, there's still uncertainty. But then we'll keep looking, we'll keep going, we'll look at more planets, we'll expand our capabilities, we'll look at planets orbiting different types of stars, more sun-like stars, and then we can build a comprehensive picture. So I don't have a favorite contender yet, but in 10 years, we can probably point to a couple planets and say, those are the ones that are most exciting.
I can only imagine if we were talking 10 years from now, what our conversation would be like on this subject. Oh, how I wish I knew.
Yes.
Well,
I'll stick around. You'll find out.
I plan to. Let's all do the same and mark our calendars.
We'll have everybody back and we'll discuss it for sure. But right now, I see people laying down the groundwork to properly think about these answers and these questions, even where a signature of something that maybe life could make isn't good enough. That's the initial detection. If we find, say, methane, if we find oxygen, Well, those need to be replenished generally. They're going to go away, but they can be replenished through natural means. So we need to ask the next question of, well, yeah, they might be signs of life, but are there other things that could be making it, and are those conditions present? So I saw it was something like 5 different degrees that were proposed, and I thought, wow, this is really getting intricate here. Are you on board with having that sort of structure behind these announcements so the public knows this is a level 4? We're really excited about it.
I think it's important to take this seriously. It's not something that we get to say again and again and again, because then it becomes a boy who cried wolf situation. So I'm very happy that the astrobiology community has been thinking about this so seriously and coming up with combinations of gases that when they coexist are better biosignatures, the indications of life. They've also come up with things that are contraindicators. So if you see a lot of O4, so 4 oxygen atoms together, that's actually a sign that the oxygen signature you see probably is not life. So by doing careful modeling and by looking at everywhere in the solar system, looking at Venus and comparing Venus to Earth, we can get a much better handle on what might be life and what probably isn't.
And do you think there's any life in our own solar system? I know there's places that could have liquid water. Mars, we're still looking, but it would be underground. What are both of your thoughts on that? Do you think one of these days NASA is going to come out with the actual smoking gun if we get the samples back from Perseverance? Maybe, what's the...
Well, they did once already, you may remember.
Yeah, of course.
There were these Mars rocks.
Allen Hills meteorite, which there's still some folks that think is controversial. They're not completely convinced, but it's not rock solid, to make a pun.
Right. I don't think we know. I think there's certainly a possibility that there's life on other objects in our solar system. And we ought to look, but I wouldn't want to hazard a guess myself, because we really know nothing about exolife right now. We only know about the Earth.
Although the Earth life, very simple life, of course, showed up remarkably soon after the Earth cooled down. It almost seemed just boom, it was there. So you wonder, well, was just the stuff Earth was made out of, was that just all the right combinations for that chemistry, the electrochemistry to go? Or we see a lot of these compounds in star forming regions. I
think most astronomers, partly because of that, think that it's pretty likely that there's a lot of life out there, at least simple life, but we really just don't know. So, that's guessing, that's not science.
Yeah, absolutely. What do you think, Courtney?
I would love to find out. I think once we do this experiment, if we find life on Enceladus or Europa or Titan, and then we can go the extra step and see what commonality it has with Earth life, if it's totally different, then that tells us that life can originate more easily. And that suggests that perhaps life is more common on planets orbiting other stars. If it's just like Earth life, then that suggests that there is probably some transfer within our solar system. So that tells us that life can planet hop a little bit more easily, but it doesn't tell us much about whether life would exist on a totally different world. On Earth, we see life pretty much wherever we look for it, but that doesn't tell us that life could have originated in all of those places, just that it can survive there once it gets there.
Right. The tardigrades seem to be able to be pretty darn hardy. Sent them to space, and a whole bunch of them, dried them out, sent them to space, a whole bunch of them came back and were revived with water. The ones that were left out in open space with the sun beating on them, very few of those came back to life, but even some of those did. It's crazy things that life is capable of. So we just don't know, like you said. Now, still myself, I think I'm with most astronomers. I believe that it's probably out there. I tend to go with do we seem like we're really lucky? I mean, does Earth seem like a particularly lucky thing, or does it seem like it's going to be common? I mean, every time we think we're unique, we're at the center of the universe, like Chris was talking about. Nope, we're not. We're just one of the others going around. Well, the Earth, the sun is the center of the universe. Nope, it's just another star in a galaxy going around that galaxy. Oh, our galaxy's the center. No, we're out in the suburbs of this bigger cluster, the Virgo cluster. We're in this group, even in the local group. We're not even a big, huge cluster. So every time our humanity is thought, this is it, we're the important part, we kind of get our priorities rearranged, and we get put in our place. But I think that's good for us to realize that we're not in a special location, we're not there, but still something special on Earth has happened. We are here to record these events. We are here to understand these events. And that's also a topic in this series, is that life and humanity, although we might feel tiny, we are also the ones that are here being able to understand the universe and learn about it, which is a phenomenal idea. Just that concept alone blew me away. It's one of the reasons I'm an astronomer, is to think we have these capabilities, we need to be using them. And one, to protect our own Earth, I think, is we should be here using these capabilities as we will. Protect the Earth and to understand our place in the universe. So speaking of which, I want to close out our topic with you tonight a little bit about the Astro 2020 that came out. Now, a lot of folks don't know what this is, but astronomers, we have these surveys called decadal surveys, where we trust some of the finest astronomers to get together, discuss what is important with research and where is it going to go and how should it be done, and recommendations are made to the country, made to the US, how the money in research should be spent. And it was just announced, it just came out. So what are your thoughts on this? Courtney, is it going the right direction? Are you happy with what the survey said? And what did it say? Let's take turns talking about it. And I'll shut up here for a sec.
Sure. So I was thrilled to read the full survey. I was on one of the panels, the panel that dealt with exoplanets, astrobiology, and the solar system. Those are lumped together because there's so much synergy between the topics. Our Earth is a planet, just like Saturn is, just like these planets around other stars are. And the stars panel also talked about the fact that the sun is a star. So these interconnections are really important, and that's interwoven throughout the report. The report identifies 3 key areas to focus on for the next 10 years. And it also sets up a funding scheme in which missions are considered and really advanced and looked at carefully before they're promoted to the stage of being developed. So that allows you to plan for longer than a 10-year timeline, which is really important. It's like planning your family budget more carefully. So the 3 themes are worlds and suns in context, which includes looking for signs of life, so the pathways to habitable worlds, new messengers and new physics, which is about really exciting gravitational wave science that you might get a chance to hear about at a future event. And the third is cosmic ecosystems. So understanding what goes on in galaxies, how they form, how the stars are distributed. These are really active areas of research. And the report then discusses how we'll explore these areas. There are 2 main recommendations. From the ground, it's to invest in large telescopes, to have US partnerships so that astronomers anywhere in the US, regardless of whether their school's a partner in this telescope, can use these telescopes. And then also to support mid-scale programs so that facilities are used to do a range of science, not just the biggest telescopes. From space, it's to build a 6-meter telescope that would be capable of directly imaging Earth-like planets around sun-like stars, and also do a variety of galactic and extragalactic astrophysics. So like a supersized Hubble Space Telescope.
Well, those are some lofty goals. Gabor, which of those do you find most exciting for your research, or what you'd like to see done?
Well, for my research, the suns and habitable worlds area is the most exciting, and they, in particular, they recognize that the question of what are the stars doing to their planets is a very important question if you want to answer the habitability question. So they put some real experiments in there to study that further, and that's kind of what I'm studying these days. So that's personally exciting. But the whole suite of things is amazing. I'm amazed, as Courtney said. I just feel really lucky to be an astronomer in these times. The field has been going like crazy ever since I was a grad student, which was quite a while ago at this point. It's still going crazy, and the public loves it. So yeah. Oh, by the way, before I leave, though, I wanted to tell your audience one thing where Nova missed a point. So at the end, but we can still talk about the decadal survey.
Yeah, no, absolutely. We'll return to that for sure. I'm excited about the decadal survey for the same reasons you're saying. The topics they've chosen to work on as major research are my topics. I was studying red giant stars in Andromeda to try and figure out how it was put together. We're getting spectra of them with the Keck telescope. Got the first spectra of red giants. We didn't get very many. It was like 29 were in my thesis. But they've gotten tens of thousands now, which is amazing. But to know that the capabilities of our new space telescopes and our new giant telescopes on the ground, we're going to be able to get hundreds of thousands of spectra of probably main sequence stars in Andromeda. We're going to be able to look at a galaxy from an external perspective. Studying the Milky Way is like trying to study the forest from within the forest. It's really difficult. But being able to have Andromeda out there to look at, and maybe even with these big telescopes pushed to probably the Virgo cluster, or probably within our realm to really look at. So I'm thrilled by that notion, the 6-meter telescope in orbit and the giant telescopes on the ground. But the gravitational wave astronomy, that to me feels like it's opening up a whole new way to look at the universe. That image of the cosmic microwave background radiation I showed, the dappled one, everybody, well, that's literally where our sight for regular light hits an opaque wall. We can't see beyond that with regular light or even radio waves, microwaves, it all, boom, hits a wall there. The gravitational waves don't. If we build sensitive enough instruments, we'll peer beyond that into the age where maybe there's primordial black holes merging back there. I don't know, but I'm just thrilled by that notion. And what do you think? Are there going to be those sorts of discoveries? Are we going to have images of these gravitational waves? Like, what's possible?
I don't know about images, but people may learn about what fluctuations were stuck into space-time way back then, and that can be extremely important in trying to understand inflation, for example, or what was going on really early on. So I think we will be hearing more about what's beyond the wall of the cosmic microwave background. Neutrinos also can come from way back then too. So there are some exciting windows to open up.
Inflation, by the way, folks, is a period of time where the universe just expanded incredibly rapidly, much faster than the speed of light. Although, again, nothing's moving faster than the speed of light. It's just space is being created. You can think of it as a little like a phase change the universe went through, and we don't understand it. It explains a lot of the things we see, which is why we use it. But it's a weird event in the universe. So that's exciting to know that gravitational waves may give us a hint as to some of that. Anyway, any other comments on the decadal survey, either of you, before let's turn to what you'd like to add to the NOVA program now that you have a chance?
I do have one thing about the decadal, which is that this year, for the first time, they included 2 panels simultaneously. One was about facilities, so the resources we need to get astronomy done, and the other was about people, because astronomy is done by people. And it was about how to support junior astronomers, particularly people of color and people of underrepresented genders. And the report has a lot of really concrete, actionable recommendations that should help the field and should help our field look more like the population of the world, which is really wonderful to see.
Yeah, I thought that was a step forward as well, and to have some action points for people to embrace, how we don't know what discoveries can be made by folks. I love to say with our school program, we're bringing kids from all over LA virtually to Griffith Observatory right now, thanks to our foundation. But it looks like LA. These kids just look, a cross section of Los Angeles. And I keep thinking, who knows who's going to be the next Marie Curie, or who won 2 Nobel Prizes, by the way, everybody, or Albert Einstein, or whomever. We don't know where this person's going to be. And it's great to be inspiring everybody. So Gabor, you were saying there was one thing you wanted to change about the NOVA series. Well, now's your chance.
So I didn't know they were doing this Age of Stars thing, or I would have said so at the time, and they may have used it. So it turns out the last star isn't really the last star. One of my biggest discoveries during my career was of brown dwarfs.
Right.
So brown dwarfs are these failed stars. They lie in mass between planets and stars, but they don't burn the hydrogen like the stars do. So they are collections of unburned hydrogen. And actually, the first brown dwarf I found turned out to be a brown dwarf binary. So there were 2 brown dwarfs in close orbit. They're a 6-day orbit around each other. And that system, it will slowly lose its orbital angular momentum to gravitational waves, actually. And it's two sort of half solar mass half 50 Jupiter mass brown dwarfs. And they'll slowly spiral in. And long after the last star went out, they will finally merge. And suddenly you will have a red
Fusion.
dwarf again.
So, all right, okay. I
long
was
after
wondering
the
about
last
that.
star, we'll get these binary brown dwarf stars will shine, and it'll shine for a long time. It's a very low mass object, so it'll shine for 1 trillion years then. So every so often you'll get one of those way in the dark future.
A sequel to the universe.
That's right.
I like that a lot. That's great.
Depending on this expansion, though, they may not be able to shine on one another, though. It may just
they might be extremely separated. Although actually galaxies will stay together. So you'll get them within galaxies, but you might not see any in the other galaxies at that point.
Yeah, very far apart. Well, thank you both for joining us. Once again, folks out there, the program Nova Universe Revealed is airing right now on your local PBS station. 2 episodes have already aired. It's Wednesday nights at 9 p.m. You can check it out. I believe even more of the episodes are available on the web. So if you're somebody that's web savvy, you can watch all 5 of them. Enjoy these. If you have questions, you can call us up at Griffith Observatory, of course, at our general number, or tune into All Space Considered. Send us an email with your questions. We always love to do those. But once again, let's thank our guests tonight. Thank you so much, Courtney and Gabor. It's been a pleasure talking to you. And hopefully when we're doing this in person again, if you're ever in LA, we'd love to have you in person to come talk to our guests once we're all comfortable doing a show without masks and whatnot in our theater.
That would be lovely.
Great to have you. Thank you so much, doctors.
Yeah,
Thank you.
Bye-bye.
so much.
Bye.
Right, folks, so let's move on to our next segment of the show.
From north to south, it appears like a skull. There we go. And this one's from Todd Kunioka. This is from Joshua Tree National Park in August. And another one from Todd, beautiful image. This one is from Red Rock Canyon National Conservation. And some more telescopic images from Anthony Perkic. This one's Betelgeuse. And the Orion Nebula. And then the beautiful Pleiades. And I had to include this image. This one's from Anthony Perkic. He actually took this morning at sunrise. This is a cloud layer over Los Angeles from Griffith Observatory.
Beautiful.
Stunning image.
Yeah.
And then more clouds. These are polar stratospheric clouds. This is from December 2019 from Sweden, from Uran Strawn. Hopefully I pronounced his name close to correctly. And this one's from him as well. This is the first snow of the season. And this incredible image, this is a transient luminous event. This one's called a gigantic jet, which is a type of lightning discharge between thunderstorms and Earth's ionosphere. This traveled about 70 kilometers in less than a second. And these occur over storms. So this is a very powerful storm over Puerto Rico where this is captured. And you can see on the right there, Tropical Storm Peter was also very powerful and active. So this graph is also from Frank Lucena, I believe is how you pronounce his name. And so you can see blue jets emerging from the top of the thunderstorm, and red sprite, the difference there is cloud to ground lightning. And this is still a topic of research to how these form specifically. So very beautiful images of some jets and sprites. Now on to some space weather. You can see sunspot AR 2882 there. This erupted the morning of October 9th, which produced a very strong solar flare and an Earth-directed coronal mass ejection. So this is pretty incredible. It's called a halo coronal mass ejection, CME, because it appears completely around the sun. And the aurora forecast from that event on October 9th, this is for October 12th, when aurora would appear on Earth. You can see more than just the green color there. So that would be a very exciting forecast to view. And then this is from ESA. This video is of the aurora from October 12th. And this is created from an image every minute from the early morning of October 12th. This is an all-sky camera in Sweden. Yes, with a fisheye lens, so you can see horizon to horizon from straight up. And this is another beautiful image from Sweden of the aurora. And I love this one because you can see the moon halo on the right.
Oh, great.
The ISS also was able to view the aurora on this day. So they captured some pretty incredible images, and we'll end the pretty pictures with these. And a good question is, are the astronauts in the International Space Station protected against these? And the answer is yes, because most solar protons cannot pass through the hull of the space station.
Right.
And that's our last image. Just beautiful aurora.
Wow. Well, thank you so much for those beautiful images, Katie. And folks out there, as always, if you have taken a beautiful picture that's astronomical or even of Earth, Earth, after all, is in space. So if you got a beautiful image, send it to us, send it to our social media, and you can enjoy seeing your picture on All Space Considered. Cat's going crazy. All right, now it's on to find out what is in the sky for you to photograph if you have the right equipment. Patrick, what do folks have to be excited about this month? Is there anything at all?
There is a lot to be excited about.
Are there any novas?
No, no, none.
Just checking. Just checking.
At least none to report in the sky report. Okay, well, there is a lot going on, and David alluded to something going on with the moon, which we'll visit in this sky report this month. In fact, on Sunday, one of the big changes is the end of daylight saving time. So don't forget to set your clock back 1 hour. What does this mean? It means that our evenings will get 1 hour darker sooner, because the sun sets at Pacific Standard Time 1 hour sooner than the previous day, which means darkness falls and you get a better chance to look at the beautiful wonders of the night sky. On the reverse end, for sunrise, you get an hour more of daylight. So don't forget to do that. And talking about the moon and Venus were together in the sky. And this picture was taken from Sicily. This shows Venus in the center there and the crescent moon from Sicily. Now, the moon does visit Venus, which is still prominent in our sky, once a month, and it makes its rounds. The next time it comes around is November 7th, the time of when the time change occurs. So you'll be able to see the moon and Venus roughly about 3.5 degrees apart from the 4-day-old crescent moon. So that's something worth taking note of as you want to take images and pictures, even with your cell phone, of this beautiful, spectacular sight in our evening sky. Not only is Venus visible at this time, there are 2 other planets, and just a few days later, the moon will be below a bright planet Jupiter and Saturn. So, and in addition, Venus is also visible in the sky as well. So 3 planets and the moon together. So don't forget to go out and take a look at that on November 10th. Now, we have our annual meteor shower. This is not a big shower, but it's the Leonid meteor shower, which occurs on the night of the 16th to the morning of the 17th. The peak hour is 4 a.m. to about 5 a.m. on the morning of the 17th. This shower produces roughly about 18 meteors per hour. They move very fast and sometimes can produce some very bright fireballs. Unfortunately, this year, the moon will hamper, the full moon will hamper observations. But still, it's a shower that's worth noted in your calendar to go out and see in the early hours of the morning of the 17th. And now for our big event. This is happening on the 18th, which is just not far from the Leonid meteor shower peak. It is a partial lunar eclipse, and it occurs on the night of the 18th through to the morning of the 19th. This partial lunar eclipse is visible in Americas, Northern Europe, East Asia, Australia, and the Pacific. And the entire eclipse is visible here in Los Angeles. So we are in for a treat here. What is a partial eclipse? It occurs when the moon is not totally within the dark inner shadow of the Earth. So when the Sun, Earth, and Moon align, it is just, the moon is just part way in the umbra and part way in that penumbra, which is the lighter part of the Earth's shadow. Now, imagine, so we're going to go ahead and look at a series of diagrams here. We can project those two shadows into the sky. You see the umbra, the dark part of the Earth's shadow, and the lighter part, penumbra. So this is the sequence for the eclipse as seen from Los Angeles and wherever you can see the eclipse. So at 10:02 p.m. Pacific Standard Time on the 18th, the moon begins to enter the lighter part of the Earth's penumbra, Earth shadow penumbra. So it won't darken much. You'll see that the moon will actually darken a few percent, but it'll still noticeably look like a full moon. At 11:19, this is when things start to be more noticeable. The northeast limb of the moon darkens noticeably as it begins to move into the Earth's dark shadow. And at mid-eclipse, which is 1:03 a.m. on the morning of the 19th, 97% of the full moon is covered by the umbra. Now, even though this technically is a partial eclipse with just about 3% of the moon peeking out of the umbra, you can see there in the south, just the southern portion of the moon, this is considered to be a near total eclipse. So we'll see all the aspects of a total lunar, all the aspects of colors of a total lunar eclipse, with the moon turning perhaps a coppery red, and which would taper off towards the south with a kind of bright orange. And this eclipse happens because we're seeing the coloration, I should say the eclipse with the coloration of the moon happens because all the sunlight that's coming from the Earth is actually filtered through our atmosphere. And so essentially all the light that falls on the moon comes from all the world's sunrises and sunsets. Now, that's hard to visualize, and we have a artist impression here. If you were orbiting just in that region, just in that 3% region where you see the partial eclipse, you'll see the sun just peeking out from the Earth there, because the Earth is actually eclipsing the sun as seen from the moon, and it's lighting up the Earth's atmosphere in that beautiful ring that you see there. So if you were to move further north, which is upwards in this picture, the Earth would be surrounded by a bright orange, reddish ring, and if you move further out, it turns kind of blue. So most of the red light is bent towards the moon, and that gives the moon that reddish color at mid-eclipse. Now at 2:47, the beautiful lunar eclipse begins to end, and the moon's western limb will appear darker than its eastern limb, and then finally the eclipse is over at 4:04 a.m. Pacific Standard Time. So that is the lunar eclipse, and we're just going to, this is a sequence of the whole eclipse. It lasts 3 hours and 25 minutes, which is the umbral portion, and the whole eclipse lasts 6 hours and 2 minutes. This next animation is what the eclipse would look like as seen from Los Angeles, from the trails of Griffith Observatory. And we're stepping through every half hour.
Now we made that for everyone because the trails at Griffith Observatory and Griffith Park will be closed. You cannot come to the park to see that eclipse in that manner, but Patrick, luckily you did provide that for them. But it won't look a lot different from your own backyard. Is that correct?
That's right. The eclipse can be, it's safe to look at, and if you're in any area where you can see the moon, you'll see that eclipse once you're out there while the eclipse is happening. So no special equipment is needed. In fact, the only special equipment that we're going to provide here at Griffith Observatory is we're going to do a live broadcast of the lunar eclipse through our telescope. And so go to our website, and you can navigate to our partial, nearly total lunar eclipse page and click on live broadcast, and you'll get to our YouTube link, where we'll broadcast this live starting on the 18th of November at 10 o'clock Pacific Standard Time. So just go ahead and do that if you want to see the eclipse up close through our telescope. Here is the link to that page. So if you can make a note of that, or you can make a note, just pause the video after the broadcast is over. You can see, you get to our link for a live broadcast. Now, this eclipse occurs early in the morning, and let's talk about constellations you can see in the early morning. We'll start with the winter constellations, which are visible in the southwest, and to the southeast, the sky is filled with spring constellations. One of the most notable constellations of the winter sky is Orion. This beautiful picture was taken by our telescope demonstrator, Anthony Perkett, who was up early morning last month. And so this is Orion, although it's lost in a blaze of faint stars, and that's because he took a long exposure of this beautiful constellation. So you can see it's overwhelmed by the faintest stars. Here we have them labeled there. This is a beautiful constellation to scan with a pair of binoculars. And don't forget to look at the Orion Nebula. It's one of the brightest nebulas in the sky and is visible to the unaided eye even in a dark sky area. Another constellation to look at, which is prominent in the winter sky, has the brightest star in the sky. It's called Sirius. And it's in the constellation of Canis Major, the Great Dog. It's below Orion and kind of to the left of Orion. Here is another long exposure image of it. You can see Sirius up there near the top there. And Sirius marks the color of Canis Major, the Great Dog. Right below it, we mark M41, which is Messier 41, a open star cluster that's visible through a pair of binoculars or even a small telescope. That open star cluster is located 2,300 light years from the Earth. All right, so those are the constellations we can see in the early morning sky, and Orion and Canis Major will be migrating to the evening sky. If you're not an early riser, just wait a couple of months and it'll be visible in the east. I'll talk a little bit more about those constellations in our next sky report. And to our moon phases this month, our new moon is on the 4th, first quarter is on the 11th, full moon is on the 19th, and last quarter is on the 27th. And there we go. So that's our sky report this month. Don't forget to join our broadcast on the 18th for our full coverage of the partial, nearly total lunar eclipse.
Yeah, and don't forget, change those clocks. And it always messes up my sleep every single time, and I don't know why, even if I prepare for it. But it is what it is, and enjoy that new crescent moon we're going to start seeing over the next few days. It's going to be a beautiful sight. Now, what about rocket launches? What's out to launch this month? Chris, what do you got?
Oh, yeah. As always, there are updates, things going on. Let's catch up on what's going on in the world of space launches. Starting off with something we talked about last month, and the mission that we're really excited about, the very first mission to the Trojan asteroids way out by Jupiter, the Lucy mission. Now, Lucy did launch successfully on October 16th. However, there has been a little bit of a snag. Literally, as a matter of fact, the mission has solar panels, big ones. They're 24 feet across. They're circular, and they open very much like an oriental fan that sweeps out into a complete circle. However, the trick is that one of the two did not fully extend and latch. Now, it's mostly deployed, between 75 and 95% deployed. It probably is okay. They may just leave this exactly the way it is. It will generate enough power. The mission can proceed. NASA mid-month is going to have a meeting and see if they want to try to command the thing to deploy again and see if it does latch this time. My suspicion is they'll probably leave it the way it is. The solar panels are critical for providing power. The reason they're so large, right now, they're providing more power than the spacecraft needs by far. But remember, it's going to be going far from the sun, 5 times farther than we are, where sunlight's 25 times fainter. So they really do need to have a good supply of power, and the big solar panels can do that. So anyway, this looks like it's not a serious problem with the mission, but I just wanted to give you an update on that. Looks like it's okay. We'll find out more after the middle of the month. I mentioned last month that the Shenzhou 13 mission of Chinese taikonauts to the Chinese space station, their new space station, was going to launch at some point in October. They did launch on October 13th successfully. They docked with the Tiangong space station, and they are on board now and beginning a 180-day stay on the space station. Space mission that we are launching over here to the International Space Station, NASA mission, using the SpaceX Dragon spacecraft has been delayed a couple of times. One time for weather reasons, not at the Cape either, by the way, downrange, the places they'd have to splash down in an emergency if there was a problem with the rocket. They had bad weather, heavy waves at sea, things like that. So they delayed for a bit. They also delayed for a little bit because of an unspecified but not serious medical issue involving one of the astronauts. They didn't say which, they kept it private. But that's apparently been resolved. They've rescheduled now for November 9th. And so we're anticipating this mission will launch on November 9. Talking about delays and things like that, we've talked about the Boeing Starliner spacecraft, not the SpaceX Dragon, the other one built by another company to provide commercial transportation to Earth orbit for NASA. The Boeing Starliner has had troubles. They had a unpiloted first test flight that did not go very well. There were glitches and problems. They were getting ready to launch another unpiloted test flight, and they had problems on the launch pad with some stuck valves. They ended up having to send the spacecraft back to the factory, and they're working on resolving the problem. In the meantime, because there are going to be delays, a couple of NASA astronauts, Nicole Mann and Josh Casada, who had been scheduled to be on the first 2 piloted test flights of the Starliner, they've been reassigned to the mission SpaceX Crew 5. We're about to launch Crew 3. This is Crew 5. Both of them will be on that, flying a different spacecraft. So kind of interesting. But that's the latest on the world of Starliner. We'll see when it flies. We've mentioned the JWST telescope we're all waiting so much on. It did indeed arrive October 12th down in South America. It is being prepped for launch now. They're performing last-minute checks. Toward the end of this month, they'll be fueling the spacecraft and putting it on top of its Ariane 5 launching rocket. We are planning on December 18 as the liftoff date on this critical mission. We'll be talking about this next month on All Space Considered. All eyes will be on this launch of this incredibly important mission. We have a launch coming up a little sooner, November 23rd here in California. A SpaceX Falcon 9 rocket will be launching from Vandenberg Air Force Base here in California. The DART mission, the double asteroid redirection test mission, a first test of an idea for asteroid defense if one happened to be coming our way. This one is not. They're just verifying a way to deflect an asteroid, change its path. By striking it with the spacecraft, it's going to fly right into a moon of an asteroid and try to change its path a little bit. This is a crucial mission. It's going to launch on the 23rd of November. The actual impact with the asteroid, just about 11 months away in October of 2022. Other things going on down in Boca Chica, Texas, the Starship program for the giant 2-stage rocket that Elon Musk and SpaceX are designing. They have been making steady progress, both with the first stage, the booster. You can see that there with the crane over the top of it, booster 4, is undergoing tests. They may do a static fire on the ground, testing the engines while it's bolted to the ground. And then also they have done a static fire on ship 20, the upper stage. That's the one with the pointy top. And you can see an inset picture there of one of the static fires they started doing in the last weeks of October. Elon Musk has said that he thinks the system might be ready to try an almost orbital mission around, like 3/4 the way around the world, to test the system. Nobody on board. This is unpiloted. As he could go as early as even this month or next month, something like that. But we're waiting for approval from the Federal Aviation Administration that looks after the safety questions on these launches. This is a gigantic rocket, as large as the Saturn V moon rocket, and launching it so close to Brownsville, Texas, well, they do want to make sure all of the safety issues are addressed. That's being looked at. We don't know exactly when the test will be cleared, but of course, we'll keep you informed. Lastly, speaking of Saturn V and moonshots and moon rockets, something maybe we haven't talked about in a little while, the Space Launch System, or SLS rocket, huge rocket being developed for NASA. It's been developed for many, many years. It's been well over budget and behind schedule, but now in the vehicle assembly building at the Kennedy Space Center, the booster has been stacked. All the parts have been put together, and the Orion spacecraft has been put on top. They're readying it for the first test flight of the Artemis program. The Artemis program is aimed at getting astronauts back onto the surface of the moon. It's a huge deal. Now, this mission, Artemis 1, will not carry a crew. It's unpiloted, but it will be launching all the way to the moon, orbiting the moon, even going considerably beyond the moon. This will be very exciting stuff, but I want to let you know it's getting closer now. It's being tested now in the vehicle assembly building, aiming towards a launch, hopefully in February, mid-February or so. But so there's plenty of exciting stuff going on in the world of space, to put it mildly, Dr. Reitzel.
Yeah, absolutely. I mean, as always, folks that want to see a launch, that one from Vandenberg, if it's like tonight, there might be too much marine layer to be able to see it from Los Angeles. But if you're there and you can get up the coast, up to Lompoc, there's nothing quite like seeing a launch in person. And those Falcon 9
Agreed.
engines, when they rumble, they really make almost a crackling noise. It's insane. The kind of crackle of those engines, the fact you see it going into the sky and then the sound hits you, it's really pretty special. One of these days we ought to get a Griffith Observatory Foundation group to go up there and see one of these launches, get our members to go up there and check out a launch with us. Would be really, really pretty fun.
That's great. Well, this one's going to be a little bit later at night, just so you know. Sometime, if we get lucky, they launch them right after sunset. So the rocket goes up into the sunset and you see it there. This will be late enough. We won't see that, but you are right. If you're close to Vandenberg up there, you will actually see the flames from the engines. It'd be a spectacular thing to see.
Yeah, it'd be very, very spectacular. Well, folks, that is our show for tonight, but I want to remind everybody that next month, we are going to be preparing for the James Webb Space Telescope launch. JWST is supposed to launch in December. Fingers crossed. I hope that all the panels deploy correctly, that everything latches correctly. This is not going out to a serviceable location. It's going out beyond the Earth and Lagrange.
No AAA.
No AAA to get to it. Even with SpaceX, you can't get there. And I actually have heard that the Russians are looking at buying seats on Dragon capsules now. So how that's turned around. So things are a little different. But sure. This is how space goes. This is how we get there. But folks, come on back next month, Friday, December 3rd. We're going to have guests, some experts, to talk to us about JWST and about the launch and the capabilities. So we'll have a show sort of centered on JWST in December. As always, I want to thank everybody for joining us tonight. Griffith Observatory presents and brings you All Space Considered. Our building is open right now on Friday, Saturday, and Sunday. If you'd like to visit, you can come on up and see a planetarium show, wander around our exhibits, and enjoy the building. Our telescopes are open every night that it is clear and we are open, but make sure you get in line early because we can't promise you a view. The clouds could roll in, and also we have got to close those telescopes at some point. So we don't promise anything, but come on up, look through our telescopes, get some amazing views. And of course, we'd like to thank the city of LA that runs and owns and operates Griffith Observatory. We'd like to thank the Department of Recreation and Parks for everything they do. That's, of course, our department, that all the folks can enjoy LA's wonderful parks. And we'd like to thank the Griffith Observatory Foundation for everything that they do for us. I like to point out our school program. Currently, our online school program has served somewhere around 20,000 kids. And we're bringing 20,000 visits from children. Some have come several times to the modules, but we are operating and bringing views through our telescope with one of the programs of the sun. Kids are able to enjoy this, and it's all because of our foundation. So thank you folks that have made donations tonight, and those of you that have joined our foundation. We're just looking forward to better and better times as we get back to more normal operation. So again, thank you, Patrick, and thank you, Chris, and thank you, Katie. And we'd like to thank our guests once again, Courtney and Gabor, professors from Berkeley, who joined us tonight, and we had a wonderful discussion. Be sure to check out Nova Universe Revealed, and we'll see you next month at All Space Considered.